Okay, so I haven't streamed in a while, so I'm mostly just figuring out how to do a setup of everything again. This time I have a fancy overhead camera, so that's giving me a view of my somewhat messy, but less messy than a has been in the past kind of desk. I mostly just want a video of this just to figure out what it looks like. I might start recording some stuff or streaming some stuff. Who knows? It's been a couple years since I've done it. But I have a fancy new mic, so hopefully that sounds good, and I kind of want to hear what that sounds like over a stream. I have some audio playing. If anyone's in chat and wants to tell me if the levels are good for a background music, that'd be good. One of the things I have up is sort of a joke, silly demo project that I have. This is for the SDR podcast. I tried to make like a physical version of that, and it's running on some hardware that I've actually built. So this is basically a USB hub, but also a power supply. So it's taking in USB PD. It's getting data from my computer. I actually have 3 Raspberry Pi boards here. These ones are kind of on top, and this one's kind of tucked in the back. This is in sort of a Euro rack kind of format. Oh, thank you, Slower Than Stone. Oh, hey, almost. I didn't recognize the alt. Yeah, I don't know what the good level for background music is. If anyone knows a good, like, how many dBm I should be aiming for background music or the separation. So it looks like my mic's kind of peaking a little over -10. Background music's maybe peaking like -30, -25. I don't know. Seems fine. We'll see if I get copyright struck on this, but I'm not monetizing it, so who cares? But so I got 2 boards. Each of them has a rotational stepper hooked up to it, so we've got power, ground, and data. And then up on my screen, I've got, oh yeah, mic's probably left channel. My mic's probably audio. Hey, Lethal Bit. Let's see if I can make the audio mono or something. So mic, let's make that mono. So now maybe you hear me in both ears. So hopefully, I always listen to music, like right now I even only have one headphone in, so whenever music like pans to one side and I completely lose it, yeah, nice and soothing. Ooh, yeah, that's thanks to Amos for prompting me to get a new mic. But yeah, this hardware setup is really just driving these 2 little stepper motors, but I figured it was a fun little demo that I had ready. Up on top left of my screen, I've got, this is PostStation. This is a tool that I've been working on. It's sort of like a reverse proxy for devices. So we can see that we've got 2 devices connected right now. They're running. I can get some information about them. But essentially this means that I can use applications or even a command line application to send messages to them. So, ooh, time for ASMR. So I can do things like post station CLI ls. So I can kind of see the same information, but this is running from a command line tool that's talking to this server, this reverse proxy. So we can see that I've got my 2 devices that are connected. And I can do things like take this command for, ooh, nope. I could take this command and I can set different numbers like 900. And you can see that one of those servos starts spinning. Or I can run a little bash script here for stop, and it stops spinning. So, hey Marvin from Fial. Yeah, this is running on top of Fial, so everything that gets logged here is essentially getting thrown into Fial, which I'm using as sort of a key value store, which has worked awesome. But yeah, so this is running. I was playing around with it, so I was just going to get the kind of the nice demo. So these normal servos, you send them a command, and that sets their position. Rotational servos, you set them a number, and that's their speed. So instead of position, you get velocity on this. The thing is, they don't come out of the box calibrated, so there's usually like a little bit of fudge. So if you notice that the amount that it takes to do stop is 720 for one and 740. I think this is, I forget what unit this is. I could look through the code. So this is a post station compatible application. So this is the actual code that runs on these Raspberry Pis down here. Let me look at what my handlers do, because essentially these little guys are acting like servers, and I send them commands and they just do something. The command that I've been sending them has basically been set the servos. If it was a positional servo, it would set like their position. Since they're rotational servos, it's setting their speed, either forward or backwards. So I am just... This is going to be in weird units. Let me figure out. I'm going to have to go look at my PWM setup code to figure out. So I think... Oh, here we go. Yeah, so the way stepper motors work is you send them a pulse 50 times a second. So 1,000 would be sort of what's called full range. And let's see, 500 would be... So theoretically, if they were well-tuned and they were good servos, 500 would be either all the way to the left and 1,000 would be all the way to the right. Or for a rotational servo, 500 would be all the way backwards and 1,000 would be all the way forwards, which means you would think 750 straight in the middle. But they're not always calibrated super well. So sometimes those numbers are a little bit off. So this isn't a very good unit. This is me taking like the raw numbers that I shove into the hardware controller to get it to do stuff. But for our purposes, like 500 to 1,000 is our range here. So if am I using fancy Trinamic drivers? No, these are very cheap SG90 servos. So you control them with PWM. So I'm actually using the hardware PWM on the RP2040. So you can see that I'm using Embassy. So I'm using the PWM driver. I set them up to be a range from like 0 to 10,000, and that's the full 50 hertz, so I guess 20 millisecond signal. And then the usable range is only like, I probably have notes here. I think it's, yeah, so 1 millisecond pulse, then 19 milliseconds of silence would be like all the way to the left. 2 millisecond pulse with 18 would be that. Anything outside of that range, the servo will maybe do something, or maybe it'll ignore me. So I'm just using hardware PWM on this, and for no good reason at all, I'm using one whole microcontroller for each of these PWM chips, but the demo is more about showing that I can talk to multiple chips at once than driving servos. So yeah, I mean, I could use the command line interface, and I could set, like I said, 500's like full speed. So that's that one, and it's going all the way one way. And if I were to make it 1,000 instead, you can see it turns and it's going way faster the other way. And I could do the same. Let's see, that was AE32. So then my other one, I could do the same command. I need to figure out autocomplete for this, or some kind of REPL, because I have the information. I just don't know the magic of how to make a autocomplete work, but that's more bash. So then I can run stop. But you can see that because it isn't perfectly calibrated, even though I set it to that stop value, now it's like, well, I don't actually want to stop at exactly this. So that makes it go faster. So what is it? 750 maybe? These are not high precision equipment. They have a little like screw dial you can put on there to calibrate them, but I haven't messed with them. So the goal is to get like a slow forward, slow backwards. But the nice thing about PostStation is I don't have to reprogram it. I just have to send it a command to set the speed, which means I don't have to reflash the device every time I want to change this code. So let's try and get reverse working. So like if stop is 720, 750, I want to just make them like kind of like slow rolling tape heads, which is the SDR logo. So 720, 750. So let's try like, well, let's see what the current code does. So I just have these little bash scripts that are just setting both of them with the value. It's an easy way to hack on it. So you can see one of them's going way faster than the other. So let's try taking this down to like 760. No, that makes that one stop. That's the wrong one. So I need to remember the top one's on the left. So I need this to be closer to stop. So let's make this like 735. See, this is the kind of thing that would be very painful to have to reflash my device after every single thing, but I can just sit here and, to be honest, I could probably run watch exec or something like that. You all probably can't hear it, but they're chattery little devices, so let me move my mic. I don't know how well that picks up or if that sounds awful, but yeah, Remrevo, so there's clap complete, and then the challenge though is what I want it to autocomplete is what devices are currently connected. So I actually need like runtime values to autocomplete here, because I need it to like run the command or something to figure out like, these are the devices that are available. And I think there is some like unstable clap command for that. I just haven't messed around with it yet. So this is sort of close. So this is like running reverse, and it's kind of if I was running them backwards, that's not a bad setup. So let's see what like the forward script looks like. And that's not bad. I think one of them's rolling faster. I was thinking about actually putting like fake tape in there, but if they aren't really speed matched, then the tape's just gonna like rip, or the motors are gonna kind of slip and stuff like that. Yeah, just I could stream servo chatter for 24/7. So I think this actually isn't too bad. Let's see if I can tweak this. I have to remember again, stop is 750, so 720, 750. Let's aim like 10 down from there. So I guess it'd be 710, 740. 710, 740. Let's see what this looks like. Okay, that's not terribly bad. Now I think that was, let's do like not 7305. Here we go. That looks, if I was really fancy, I would have some kind of like closed loop control, so I would have something that's like measuring the speed of them, but this was like, I spent like 3 hours, and most of that was cutting out pieces of foam core board just so I could do this. But yeah, I just wanted to do a real easy demo because I want to hear what this audio sounds out. There's work on a Rust native completion engine, but because Rust startup time is fast enough. But anyway, yeah, that would be very cool. If there's a way to do it, I'm very interested in it, because I need to basically run something. Like it could be a hidden command line call. Like I have that post station. Like I have ls, which right now it prints like a little markdown table, but I need to get this column's worth of data basically, or I think I might have some commands working with the names so that I could be like, send a command tab on serial, and it would like let me tab complete through the first, probably the serial devices that are connected, because you can't really proxy messages to devices that aren't connected. But yeah, I just need to know more about shells, and that's one of those abysses that you have to get into. But yeah, now I can run stop. If I did want to reflash one of these, so I also have the ability to, let's see, if I do PlayStation CLI devices, or what is it? It's endpoints. So endpoints are like, what APIs does this device have? And this gives me a listing of them, but I have a command for pico boot reset. So if I were to run my proxy command again, and instead of sending it to the servo set endpoint, I do pico boot reset, and this message, I'm just going to send it an empty message. So I'm going to hit enter, and we're going to notice one of these devices goes away. So X-Ray just went from connected to disconnected because I sent it a command to reboot into the bootloader, so it rebooted into the Pico bootloader. So now I can do since in Cargo Run, I have it set up so that when you run, it calls Pico tool load. So if I do a Cargo Run release, because I'm in my firmware project, it's going to build, it's going to flash, and we'll see that the device comes back online. So if I had edited my firmware or whatever, that's all it takes to reflash the device if I do need to reflash it. But for most of this stuff, I don't usually need to reflash it because I'll just make endpoints for like all the set motor speed, blink LED, read a sensor or something like that. And I could also write like a little command line application. So instead of using the CLI, I could use just the SDK for this. But yeah, that's not something I'm prepared to do at a 10:45 on a Sunday night. So I think this was a reasonable demo. I appreciate everyone who showed up in chat to give me feedback on audio levels and stuff like that. And I can check out my different scenes and stuff like that. Screen only. But yeah, I just mostly wanted to see if all the equipment still worked, how my computer handled it, because I don't think I've ever streamed with this computer before, and it's handling it much better than my older laptop. So thank you everyone for watching. I'll probably wrap up for here, and maybe I'll stream again, because this was kind of nice, or at least show off some stuff more often. It'd be cool to be able to hop on, record like 10 minutes of stuff, and then put it out without having to stress an editor about it, and then maybe cut clips from that. But yeah, thanks everyone for watching. I'm going to wrap up. Hope you have a good rest of your weekend. Have a good night.